Welcome to week 2, Thursday, level C math. And if I click on the icon for the Lego guy, shape-shifting, changing one number, we're almost done with this topic. We've done everything about rounding, about fractions, about percents, and changing between percent decimal and fraction format. So the next topic is measurement. Oh, also, you don't need to do attendance. I'm just taking attendance as we go. So. Okay. So for measurement, we just start with some story time. You can take notes if you want, but there's really nothing I will say that's not right in the online notes anyway. And this is just because before we get into the math about measurement units, part of being a responsible, well-educated person who can bore people at coffee shops and cocktail parties is to know about the history of all these measurement units. So we're just going to talk about measurement units to start off today, what they are and their history, and then we'll get to the math. So our definition, a measurement's unit is the word that labels the measurement. No surprise there. If I say I'm 63 inches tall, the measurement unit is inches. I'm gonna make things bigger. By convention, when we talk about units, we talk about the plural. So if a box is 1 yard tall or 3/4 of a yard, we would still say the measurement unit is yards. No one will actually test you on that, but we can have rates that compare things. We talked about that last time. So rates will often involve 2 units, like a speed limit of 30 miles per hour. And there are measurements that have more than 2 units, but we won't ever use them in our class. For example, a 20-watt light bulb, a watt, is actually the rate of power of moving a weight of 1 kilogram at a speed of a meter per second when resisted by a deceleration of a meter per second. But we don't care about watts, thankfully. They are complicated. Okay, so we have these measurement units, and what are we going to do with them? Where did they come from? The older system from Europe is now named the standard, the American, or the imperial units. You can call them whichever name you want. The newer system is officially the SI, System International, but most people still call it the metric system because that's the older name. And we are lazy and use the old name. For length, many European countries had lengths named the inch, the foot, and the yard. And the inch was the most important. If I was measuring my field to build a fence or to sell you some property, then the accuracy wasn't too big a deal. But if I was a carpenter, I needed all the pieces to fit together. And I wanted the legs of my table to be the same length so it wouldn't wobble. So the inch was the important one. So an inch, everyone, and if we were seated together in a room, we could actually do this. We hold out our thumb and take the width of your thumb at that thick knuckle. And you take the average value of thumb width for a few men in the town. And that had very little variation based on where in Europe you lived. Adults just sort of have similar thumb widths. So that worked. If we did that in every town, I could make pieces for carpentry in my town, and you could make them in your town, and we could put our pieces together, and it would all fit. 12 inches being in a foot was a remnant of the Roman Empire. A foot was always 12 inches, and this was always longer than people's actual feet, but was pretty similar to a big clunky boot length. So if you stepped heel toe in big clunky old-fashioned boots, you could measure out the feet that a field was wide. Yard meant a few things. It was about a stride length. It could be 3 feet, or the average belt, the circumference around the waist for people, or 2 cubits. So if you touch your fingertips together with your elbows out like wings, the distance between those 2 elbows is 2 cubits, right? Fingertip to elbow twice. In any case, it was about that way. And if yards were based on feet historically, then the yard was 3 feet, but that wasn't always true. The original mile was 5,000 Roman paces, and people stopped using paces but kept the mile. And that's why a mile is 5,280 feet. It's a funky number, but it's sort of related to this older thing. And there's a link if you're curious where we get the 5,280 from. So that's inches and feet and yards and miles. So the metric system was created in France in 1791, and they decided the length would be called a meter and defined it as a 10 millionth of the distance from the equator to the North Pole through Paris. And the through Paris is important because the Earth is not actually completely round. If you go from the equator to the North Pole, then how long a trip that is depends on where you start heading north. How long was the meter? It's the same meter we use today, and it was absolutely amazing. The expedition that was sent out to measure this was only off by a 50th of a percent, which was remarkable considering the tools they had then. But the meter was not quite the originally intended length. It was off by a tiny bit, so people adjusted it a little bit in the years to come. In 1889, people decided we needed an actual thing to compare to. So if I was a laboratory scientist, I can go and travel and take my metal bar and see exactly how long a meter is. So people built the International Prototype Meter. This was a bar. It was made out of platinum and iridium, some things that wouldn't change size when you got hot or cold much. And they marked with 2 lines a distance apart that was the official meter. So anyone could visit Paris and borrow this for a moment and mark on their own bar how far apart a meter was, and take it back home, and then we could all make things that were the same size for our laboratory work. Many of the rulers that we have today have one side with inches and feet, and the other side has centimeters and millimeters. In the 1950s, much more recently, people decided that since the meter had this official object to define it, but the inch didn't, then the meter sort of got priority. So in 1958, the inch was redefined to be exactly 2.54 centimeters, which didn't change it very much, but now it was easy to not have some rounding. Yay, Tafuf is here. Then in 1960, the meter was redefined. By this time, technology had advanced enough that scientists all over could build a certain kind of laser. So they defined the meter to be 1,650,763.73 wavelengths of a certain kind of light. And they tried to not change it, which is why they picked such a funky number. But this way, you wouldn't have to travel to Paris anymore. You could use this thing with lasers and mirrors and spinning the mirrors around on a table. If you want to visit building 16 and look at the physics labs, they might have such a thing set up at certain times of year. But there's this cool way to bounce a laser light around on a table between rotating mirrors, and you can measure exactly how long a meter is. In 1983, the meter was defined again. Now there were other kinds of lasers that were even cheaper to build. So they defined it as about 1/300 millionth. You can see the number is not actually 300 million of a light second. How far light travels in 1 second, divide that by about 300 million, and that's a meter. And again, it's a funky number because they didn't want to change it from the bar in Paris. A meter is broken up into 100 centimeters. How could we remember that? What does centi sound like?
Middle.
I'm sorry, what did you say?
I said cents.
Cents. Okay, yeah, 100 cents in a dollar, 100 centimeters in a meter. So cent means 100, like per cent also. A meter could be broken up into 1,000 millimeters. Oops, so there's also century and millennium. I gave you those words. So milli is 1,000. Okay, that's our length story. Now we'll talk about mass. The Roman Empire used weights from which we get the words pounds and ounces. And we needed something that people all over Europe could get the same value for. People's thumbs were no longer the answer. So what they decided to use is barley corn. The grain was small and uniform. So usually an ounce was either 450 or 480 grains of barley corn based on where you were living. The Roman pound was 12 ounces, which meant you could divide it into threes or fours. But soon after the Roman Empire ended, most European merchants switched to a 16-ounce pound. And 16 is better than 12 if you are using a balance scale. If you picture those scales that have little hanging dishes, then if you want to cut something in half, you can put that so they balance, and that's half and half. And if you cut those in half again, you get quarters. And if you cut those in half again, you get sixteenths. Whereas there's no way to actually cut something in thirds on a balance scale and get 12 out of stuff. So 16 was easier for people to chop things up and make sure that you and I were getting a fair share. For the metric system, a gram was defined as how much mass would be 1 cubic centimeter of water. So if you picture like a 6-sided die, it's about a centimeter on each side. And so if you fill that with water, how much does that weigh? It's a small amount. It's great if you were doing chemistry in the laboratory. It's not really practical if you're measuring your kid or something bigger. So 1,000 grams is a kilogram. That's what we often will use more in real life. Why wasn't a cubic meter of water picked? Since a meter is the standard length, why not use a cubic meter in its entirety instead of just a cubic centimeter? And the answer is it would be way too heavy. Imagine an aquarium that's like almost a yardstick on the side. If you filled that up with water, it would be immensely heavy. I've been using the word mass, which we often think about as weight, but technically they're not the same. The weight of an object will change based on how much gravity you have. So if the moon's gravity is 1/6 as strong as Earth's gravity, and on Earth I weigh 162 pounds, how much do I weigh on the moon? If it's 1/6 as strong, I would take my 162, divide by 6, and I only weigh 27 pounds on the moon. So officially we should use mass, but if you talk about weight, no one in this class will care. My mother used to have a t-shirt that said, "I'm not overweight, I'm just on the wrong planet." Questions about length or mass before we go on to volume?
Good here.
Anyone know more history than I do? You might. Okay, I'll keep going. So volume isn't used much. People are just not very good at staring at two things and knowing if they're close, which one takes up more space. You could play this at home with your kids, take out different sizes of mugs and cups and thermoses and try and sort them biggest, smallest, and then fill the biggest one with water and make sure that, yes, the next one overflows as I go slightly smaller. And you'll see that if you have a bunch of these, you probably make some mistakes. We're just not very good at different shapes of how much space something takes up. And when volume was an issue, it was often just jargon, what the merchants would use for actually talking about weight instead. So a gallon was originally how much space 8 pounds of wheat would take up. But now we have scales and stuff for weight, and we also have measuring cups. So the volumes for our measurement system have been standardized. We have an official cup. It's not just whatever cup you're holding in your kitchen. And a cup is 8 ounces, or 2 cups is a pint. And if you have 2 pints, that makes a quart, and 4 quarts, that makes a gallon. If you're someone that is a baker or a canner, you might know these already. So let's look at a picture. That's a way to help remember these. Imagine that this box is our gallon at the top. Then we chop it up into 4 quarts, and that name sounds like quarters. So the quarts are the quarters of the gallon. If you buy sometimes juices at the grocery store are in quarts, and if you stack 4 of them together, it's about the same size as a gallon, except there's often air at the top. The quarts are 2 pints. If you buy heavy cream at the grocery store, it often comes in a pint container, which is half as tall as the tall, thin quart ones. And then a pint is 2 cups. Think about the short 1-cup milk cartons from elementary school. So you can put all those together and make the last picture. The gallon is the whole box. A quarter of it is a quart. The 1/8 of it are the green pints, and the 1/16 of it are the blue cups. As a silly story, mind your P's and Q's. Pubs in England used to give credit to their regular customers. You'd only get paid once a month. And in the meanwhile, the bartender would put your name on the wall and mark P's and Q's whenever you ordered a pint or a quart. And at the end of the month, you'd have to pay your bar bill. So it is kind of funny that we say, mind your P's and Q's to little children these days, when it really meant don't drink too much before payday. And that's another tangent. We're in Willamette Valley. This is the grass seed capital of the world. There's something called a dry quart. If you or your family are involved in that, don't confuse the rest of us, please. Okay, remember how your 6-sided dice little cube was filled with water, and that was a gram? Then that same size cube they wanted to use for the metric system for space. So they defined it as the milliliter, how much space it takes when you make a cube where every edge is a centimeter. Some places use cubic centimeter instead of milliliter. If you work on motorcycle engines, they're measured in cc's. If you are a nurse giving injections to people, the shots have cc's. I'm not sure why some places have milliliters and other places have cc's, but they're exactly the same thing. And this is pretty small. So we often will talk about the liter, 1,000 of the milliliters. And that's, we're talking about juice bottles and things like that. Okay, that's the end of our short history lesson. Questions about any of that?
Not here.
We don't have any homework for it. It's just kind of a history lesson. But now we get to the math. So I don't have free textbook codes for you today. I hoped I would, but apparently it's taking longer. But later on, if you want, look in the book. We're in chapter 7, sections 1 and 3. And the math about measurement units that deal with one number at a time is how to convert from one measurement unit to another. And we'll do this either by multiplying or dividing. And most people in our class are most familiar with the standard American imperial system, whatever you want to call that one. So our initial example problems are 12 inches or a foot. So first we can ask 7.5 is how many inches? So if I take that one and stick it on the Jamboard, then my question for you is, are we going to multiply or divide? 7.5 feet is how many inches? If we multiply by 12, then we're going to get something bigger. If we divide by 12, we'll get something smaller. So which one should we do for going from feet to inches?
Multiply.
Multiply. So I don't happen to know what that is off the top of my head. I'll take out my calculator. 7.5 times 12 gives me 90 inches. And how did you know that multiplying was the right one?
Because there's 12 inches in a foot, so most like there's like more that goes into a foot, I guess.
Yeah. So what my notes have to paraphrase that is we're splitting apart each of those feet into 12 inches. We're breaking them apart. We're distributing. We're shattering a bunch of 1-foot rulers, something like that. You can say that a foot is made out of multiple inches in the same way that a 15 is multiple threes. The bigger thing is several copies of the smaller thing. So feet are multiple inches, yards are multiple feet or multiple inches, miles are multiple yards or feet or inches, and so on. In the same way, pints are bigger than ounces. They're a multiple of ounces. Quarts are a multiple of pints or ounces, and gallons are a multiple of all of those, and so on. So if we are going from something to something else, and we're starting with a multiple of the smaller one, then we multiply. It sounds the same. So unsurprisingly, if we do the other one, "30 inches is how many feet?" Now am I going to multiply or divide?
Divide.
Divide. So to go from 30 inches into feet, we are grouping together sets of 12 inches, and that makes a pile of inches that's a foot. You can imagine fusing them together or bundling or gluing them or something like that. We could say that an inch is a factor of a foot in the same way that 3 is a factor of 15. Several copies of the small thing make up the bigger thing. So when we are, here's our cute memory device. When we're converting from a multiple measurement unit, so feet, we're going from, and it's multiples of the inches, then we multiply, because multiple and multiply. If we're converting from a factor measurement unit, inches are a part of feet, they're like a factor of feet, then we divide, because when we think about factors, we think about division. Make sense?
Yeah.
Yes.
If you have enough brain space, then if you do it the wrong way, you'll catch yourself. If I took 7.5 and divided by 12, and I got 0.625, less than an inch, then I should think to myself, wait a minute, something's wrong. I know 7.5 feet is taller than me. That has to be more than an inch. But on a test or at the end of the day when we're tired because we've been dealing with work and kids and stuff, then we don't always notice when we make a silly mistake. So having the tricks here is nice, not only to do it right the first time, but so we don't have to rely on catching ourselves and trying it twice. So these are what we call one-step conversions, which I will put on the Jamboard. And by that, we just mean you can take the original measurement unit, whatever it was, and do one thing to get what you want. You have to know the rate that compares the old ones and the new ones. So let's do a bunch of these. And I'm actually going to grab this thing too while I'm at it. Okay. How many inches are in 5.75 feet? Did we just do that one? No, there's 7.5. Just looks kind of similar. Okay, so I'll take my 5.75. Am I multiplying or am I dividing?
Divide.
No, I'm starting with feet.
Multiple.
Well, feet to inches. The feet are a multiple of inches, so I am multiplying. And it's 12 inches to a foot, so it's going to be 12. Someone else, you can do this on your calculator. Call out the answer when you get it, and I'll write it in. I'm more interested in setting up. How many
69.
feet? What?
69.
69 inches. Okay. How many feet are in 198 inches? So I'll take the 198. Am I multiplying or dividing? I'm starting with the inches.
Dividing.
Dividing. The inches are a factor of the feet, so I divide. It's 12 that connects inches and feet.
16.5.
16.5. Okay, thank you. How many cups are in 12 gallons? So are gallons a multiple of cups or are gallons a factor of cups?
Multiples.
Multiple, they're the big thing that the cups are made out of. And how many cups were in a gallon? If we don't remember that, look at that picture. So 4 and 4 and 4 and 4.
Sixteen.
16. Or if I have 40 cups and I want to go into gallons, now am I doing a multiply or divide?
Divide.
Divide. The cups are the small thing. They are the factor of the bigger thing. Okay, and it's again 16 is the number that connects cups and gallons.
2.5.
How many ounces are in 152 pounds? Are pounds the bigger thing or the smaller thing compared to ounces?
Bigger.
Bigger. Pounds are multiple ounces. So we're going to multiply. And remember, it was 16 ounces in a pound, which is also why they made cups and gallons of 16. Two, 4, 3, 2, big number. Or if I have 152 ounces, now I'm going to the pounds, the bigger thing. I'm starting with the small thing, the factor of the big thing, so I divide. 16 connects ounces and pounds.
7.5.
LBS is pounds, if you haven't seen that one. Okay, questions about this? Could you do more of them if you needed to on homework?
I'm good.
I get it. Thank you.
Okay. There's other ways to do this that we'll get to soon. Okay, again, there's a video. Click the video or the steps or the answer. And then the homework problems if we have the book. We've already seen some examples of metric prefixes. A kilogram was 1,000 grams. A milliliter was 1,000th of a liter. A millimeter was 1,000th of a meter. A centimeter was 100th of a meter. So these are part of a general pattern. Kilo means times 1,000. Centa is divided by 100. Milli is divided by 1,000. And micro is a millionth, which you'll usually only see in normal Eugene real life with micrograms. If you take medicines, there's so many micrograms of the active ingredient in your medicine, a millionth of a gram. Oh, okay. So here's what the list actually is in its entirety. On the biggest side, kilo means 1,000. I have that in red. There's something called hecto and then deca. That means 100 of it and 10 of it. But even in Europe, you'll seldom see those. In green, we have whatever the plain unit is. Is this meters or liters or grams or something we don't talk about like watts in a different class? The deci we won't see in the US, a tenth of something. But centa and milli for hundredth and thousandth we see all the time. Then oddly, there's dots. There's no official prefix name for the 10,000th of something or the 100,000th of something. But micro is the official name for the millionth of something. We don't actually need to know all these. What we will actually care about most, for a reason I will show you very soon, is just the initials. So K is for kilo. H and D, hecto and deca, we don't care about too much. The unit, this is where we have either meters or liters or grams. The deci we don't care about too much. The centa is 100th. The milli is 1,000th. And then micro is the millionth. Maybe it would even help for me to write that this is 1,000. This is one of the thing. This is 100th. This is 1,000. And this is 1 million. And this should look a lot like what we started the class with. No, it doesn't mean that. When we made these place value things, right? So it's the same kind of thing with place value that we did at the beginning. Oh, okay. Why do we care about this list? Because there's a cool shortcut. You'll want to be able to make this list, and you could always look it up in your notes, but this KHD, UDCM, bump bump micro, at least the part before the bump bump micro, people have cute little things they memorize. So King Henry does usually drink chocolate milk, is the most famous, KHDUDCM. I like killer hobos dance under dazzling crystal mobiles because that does usually, you can put in either order and mess yourself up, but this one you can't mess up. So we have a nice shortcut, and this is why the rest of the world thinks America is silly for not switching to the metric system. So the shortcut says, to convert between the metric prefixes, first write that list we just did, and then count the decimal point scoots. For every place you go left or right, move the decimal the same way. So I'm going to do a problem first this way, and then I will do it with the shortcut, and you can compare them. So how many millimeters is 2.8 centimeters? So we could say that there's 10 millimeters in 1 centimeter. And so we'll take our 2.8 centimeters. It is the bigger thing. It is the multiple of 10 little millimeters. So we're going to multiply. Should do it. So we'll multiply by the 10, and we'll get 28 millimeters. Or we could just take these initials and say we went from centimeters to millimeters, which was 1 scoot to the right. So that means all I had to do was take my 2.8 and also scoot that decimal 1 point to the right. Again, just for the sake of completeness, in this case, our unit was meters, and the prefixes we cared about were centi and mil. But I wouldn't normally write all that. Let's do some others. A backpack weighs 6,480 grams. I could do this the one-step conversion way. 6,480 grams. The grams to kilograms was at 1,000. Am I multiplying or dividing?
Dividing?
Dividing. The grams are the small thing we're starting with. They're like a factor of kilograms. Factor reminds us of division. Divided by 1,000 was 3 decimal scoots. So we get 6.48 kilograms. I could even put the 0 here if I wanted. I am not bragging. I really did have that much accuracy because I measured it to the grams. But if you leave out the 0, that's fine too. Or if you didn't live in the US, then you would be used to the shortcut, and you can just say, hey, I was going from grams, my plain unit, to kilograms. So that's 1, 2, 3 to the left. So I will take my 6,480 and go 1, 2, 3 to the left and be done. we had seen yesterday how decimal point scoots always, with these tens and hundreds and thousands times and divided by, just scooted the decimal around. So that's why this trick works. Okay, I skipped over some. Let's have you do them to make sure you understand the trick. Oops, not there. So first we're doing 16 centimeters is how many meters? And then we're doing 16 centimeters is how many millimeters? So tell me what to write. Where am I starting in my Killer Hobos Dance Under Dazzling Crystal Mobile?
Crystal?
Yeah, the C for centa. And I'm going first to plane meters, which is the only tricky spot. Where's plane meters on my list?
To the right of it.
It's the plane here, the unit, right? So I'm going 1, 2 to the left, which again, you could just do in your head and not have to write it out. So 1, 2, so I get 0.16 or 0.16 since I'm lecturing. How about going from centimeters to millimeters? This is what you were thinking before.
You going to the right?
Yeah, it's from centa to milla, centa, milla. So 1 to the right. What do I do when I sort of go to the right of something?
Add a 0.
Add a 0. Ta-da. So you don't have to write out any times, tens, or divided by hundreds or things like that. Okay, one more just to see if you were awake when I did my history lesson. Since it's the end of the day, if you're not, no one will blame you, but we will check anyway. So first we are doing 450 cubic centimeters is how many milliliters, and the L is capitalized in this case. And then we're doing that into plane liters. Oops, sloppy writing. Oh, okay. Liters, they capitalize because otherwise it looks too much like a 1 and you wind up multiplying by 1 and getting the wrong answer. So who remembers, what's the difference between cubic centimeters and milliliters?
I don't remember.
If we took a box that was 1 centimeter on each side, then that amount of space was both of these. That was the definition of a milliliter, and it's a cubic centimeter, just because it's a cube made out of a centimeter. So those are two names for the same thing. There's no change at all. That was my were you fully awake in my story time. So I'm actually going to change CC to be easier for you and say milliliters here. So from milliliters to plain liters, where am I starting in my letters?
M.
M, the milli. And where am I ending up?
Unit.
The plain unit. So liters. So 1, 2, 3 to the left. Again, you don't have to write all this out. 1, 2, 3 to the left. So 0.450. You could leave out this 0 if you wanted, but we did measure it that accurately, so you can keep it too. Should we do more of these? Are you ready for homework?
Can we do a couple more, please?
Sure. So do I have a random ones? Yes. That one. One. And that one. Okay. So the average distance between coffee shops is 6,281 meters. And I want to change that to millimeters. So I will write out my letters. Filler, hobos, dance, under, dazzling, crystal, mobiles. I don't actually need the dot dot micro because there's no micro stuff happening here. Where am I starting?
Unit.
The unit, plain meters. And where am I going to?
M.
M, milli. So 1, 2, 3 to the right. 1, 2, 3. I need to put 3 more zeros on. Lots of millimeters. I'll do all of them and then ask the questions. So we have 367,081 grams. And I want to know how many kilograms that is. So I write my things. King Henry does usually drink chocolate milk, dot, dot, micro. Where am I starting?
Unit.
Unit, grams. And going to
K.
K, kilo. So 1, 2, 3 to the left. 1, 2, 3 to the left. So we get 367.081. And yes, we really had measured it that accurately. In real life, I might round it. Lastly, a crate has a length of 281.367 centimeters, and I want to go into millimeters. So I will write out my things. Filler, hobos, dance, under, dazzling, crystal, mobiles. Where am I starting this time?
C.
C, Penta. And where am I going?
M.
M, vanilla. So 1 to the right. So look at the steps I did. First, I rewrote things. When I'm tired and I just look at the sentences, I sometimes try things backwards. I get confused over where I'm starting and where I'm ending. So I always like to rewrite it. It doesn't take that long, as this many things is blank this thing, and kind of making it look more like Mad Libs and less like a paragraph just helps my brain. Feel free to skip that step if you don't need it. But I've done enough of these when I'm really tired that I like writing this part just because it makes it really clear. This is what I'm starting with. This is where I'm going to. Then I put down my letters and pick the starting and the ending and count where to go. And then I do the same with the decimal. Any questions?
I think I'm good.
I understand.
Let's do one with micro, just because we happen to not get any micro so far. So medicine as 2.8 milligrams, or maybe we'll even say 0.28. That would make more sense. So 0.28 milligrams is how many, and mcg, if you're going into nursing, this is the abbreviation for micrograms. So now I have to write all my letters. Killer hobos dance under dazzling crystal mobiles, dot, dot, and the micro. Starting in the milli, going to the micro, 1, 2, 3 to the right. 1, 2, 3 to the right. I go off the edge. I need a 0. Ta-da. Okay, now you've seen micrograms too. Okay. So videos, homework, blah, blah, blah. The last thing we're going to talk about are exponents and square roots, because when we have measurement units, sometimes we have square units, like square feet, square meters. So we need to talk about this kind of thing. If we have a simple square, like 1 foot by 1 foot, we know that the area of a rectangle is length times width, squares too. So the area of this is 1 foot times 1 foot, which is a square foot. When we say this much paint would cover 1 square foot, then that's what we need. So that area we could write it a few different ways. I will often write it SQ period feet, like that, just to kind of be abbreviated. Some people will write 1, and then that's a squared foot, just like 2 squared equals 4. Since we're used to saying that that is pronounced squared, they will use that same thing there. So any of those are okay. I'll usually use this one when I'm writing, just because if I write sloppy, having a 2 in the way could be dangerous. If we changed from feet to inches, then what do we do? So now I have broken apart my square, which is the same size, into inches. If I do length times width, 12 times 12, then I'm going to get 144 square inches. Everyone see the 144 happening?
Yes.
Yes.
So it's a really, really, really common mistake that if you're going from square feet to square inches or back and forth, to use 112 instead of a 12 times 12, just because we're used to 12 being feet and inches. But when you're talking about squares, you have to break apart each direction. You have to break apart the length and the width into 12 things. You can't just do only one. Okay, so each of those little things is a square inch. I could count them all and make you really bored and count up to 144. As a side note, what's the difference between these two things? So if I have 2 squared feet, then that one is 4 feet. It's a length. I have 1 foot of a ruler, 2 feet of a ruler, 3 feet of a ruler, 4 feet of a ruler, right? My kid is 4 feet tall, something like that. If I have this one, this is 2 square feet. So I have 1 square, that's 1 foot on a side. And then I have another square, that's 1 foot on a side. And I'm shading them in. That's how much area they take up. So completely different features. This is a long length. This is like a domino. See why I don't like this notation as much? It looks too much like that one. Okay, and actually we just talked about square roots. So since we did, let's be clear, because it was a little subtle. The square root of a number is the amount that when you multiply itself gets up to that number. So the square root of 25 is 5. I can take this paper picture and we'll write it out. The square root of 25 is 5. And all that's saying is if I drew a square with 25 little boxes, what would the side be? It would be 5. Since this is a lot of writing, then you will often see a shortcut that says the square root of 25 is 5. But don't let the symbol confuse you. All it's saying is draw a picture with 25 tiles and each edge would be 5. If we did instead the square root of 81, what would that one be?
Nine.
9. If I have 81, that's 9 times 9. Okay. Most numbers don't have pretty square roots. I happen to pick 25 and 81 because they do work out. But if I say that this box has 6 square inches, I can't really draw that well. It doesn't work out nice. So how big would the edges be? We just take our calculator and use our calculator buttons and say square root of 6, and I get that it's about 2.449, I'm rounding. And that's perfectly fine. In the old days, you'd have to look things up in a table or use your slide rule, but we are modern high-tech people. Take out your calculator, or if you don't have one, then go, oh, come on. Go to the Desmos calculator and just say square root of 6 and get your answer, right? So it's not cheating. There's no better way to do it these days. The numbers that do have nice whole numbers we call perfect squares. So 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9. Those are the perfect squares, but most numbers aren't perfect squares. And we have videos, we have example problems, we have homework things to do. Some of these you could actually do because they're in the free section, chapter 1. And then when you're done, your 10 exercises for shape-shifting measurement and some random exercises to try. There's an interlude that you can read on your own. And ta-da, we are now done with shape-shifting. We've seen a whole topic already just in 2 weeks because it's kind of a short review topic. So first, I want to ask questions just about the things we talked about, the measurement topics, converting between measurement units, exponents, square roots. No question. Oh, okay.
No, I'm good here. Thank you.
So all these random exercises, those are the ones that if we go to the shape-shifting test, up here, there, they're just all stuck together. It's still true every time you load it, the page, the numbers change, and the answer key is there so you can see how you do. Now that we've finished shape-shifting topics, then try this. We're not going to have an official graded midterm because we don't have graded things, but it's a great thing to do after this. And there you go. What I can offer to do that is often popular is that we can take one of these shape-shifting tests and I will save it as a PDF document. So we all have the same one. And then for class on Tuesday, we can all work on it together. And just be a good review of all the things we've done. Would that be a good use of time on Tuesday?
Yeah, I'd like that.
That'd be a good idea.
Okay. If you want to work on it by yourself, then I'll put you in a breakout room in Zoom so that you're not bothered by other people's talking, but you're still here so that you can flag at me and get help whenever you're stuck. And if you want to work with people, then that's great too. So I will make a note to save these. Let me put it in chat. On Tuesday, we will do a why is it jumping over me? Shape-shifting test together using a PDF file. Okay, I have that note to look at. Okay, then I also just kind of want to check in. So we're going to just keep going. Maybe not immediately, but we'll start mad science, everything about smashing numbers together. We'll talk about multiplying and dividing fractions, adding and subtraction fractions, mixed numbers, order of operations, terms, percentages with other numbers, measurement units that work together instead of one at a time, some basic geometry. So that's where we're going. I want to check that our procedures are okay before I assume they're working. So I've been asking you to come to the Zoom sessions. If you miss it, then check in by meeting me in Zoom or sending me a quick video of you doing some homeworks. Either be in a study group, which most of you are, or do the Moodle discussion forum to connect with people because it can be lonely. We're still on the shape-shifting page, so review the notes after class. Use the video links and textbook sections. Once you get the textbook, practice with those problems. When you get to the 10 exercises, try those. You've been very good about that. Thank you, all of you. If you want yet more practice, use the random exercises and explore the website if you haven't yet. Also check in and tell me which achievements to check off. And then you get the recordings. So that's our thing. Is this working well? Do you need different routines? Should I try and plot out in advance where we are on the calendar better? Or is it good enough to just put on the calendar that shape-shifting rounding was due today because no one had questions last time, and so on? Any kind of procedural feedback to give me?
I think it's good.
It's working fine for me.
Oh, okay. The one thing I will say is that so far no one has used our Get Help forum, which is fine. I realize that it is seldom used, partly because it's easier just to send me an email or a text than to actually visit this week. But if you do ask a question here, it helps everyone else because they are also having the same questions you are, they're just not asking them. So there will always be other people in class. And there's actually 18 people in our class. It's just a lot of them are not doing the synchronous Zoom meetings with us. So do more Get Help forums. We aren't in a rush. It's also easier and popular to just wait till the next class and ask me in class. Before we get started, can we do this homework number 4? But consider the Get Help forum. I'm sort of advertising that now because it's a Thursday and you won't see me in Zoom until Tuesday. What else? Oh, there may be more. No one showed up yesterday at 1. People had asked for a 1 o'clock Wednesday study session, but then it didn't happen. That's okay. I got other stuff done.
I was gonna do it, but I was at work.
Oh, okay.
I couldn't get a that time.
Is Wednesday at 1 normally a good time, or should we try something else on Wednesday?
I'm normally off on Thursdays, but it's really random when I get off because I'm a housekeeper. It depends on when I finish.
Okay. Should we make some plans between now and when I will see you in class on Tuesday? Anyone want something tomorrow or over the weekend?
Tomorrow works for me.
Anyone else want to meet with Lily and do some homework together tomorrow? Is Fridays good for people?
What time are you thinking tomorrow?
I'm free all day because I'm off, except for at 3, I'm going to get my COVID shot.
I'm not home from work until like 3:30.
Okay, so how about after, like, how does 4:30 sound?
I can make that work.
Yeah, that's doable.
At 4:30 tomorrow. Usually Fridays I'm busy right then, but it's canceled tomorrow in particular. So 4:30 tomorrow, I can be there too. So when they put in the Zoom chat, Friday, 4:30 p.m. study session. And in future Fridays, if my normal thing is not canceled, then I will just show up at the end, and whatever questions you have after working together, I will help you clean up those questions before you're done. You can start without me. The Zoom room is always open. It has no password. Anytime you need to. On a related note, I've been light about keeping your emails anonymous. Is there anyone that would mind if I, instead of BCC, just send out the after class emails in a way that lets you see all each other's emails?
Doesn't bother me.
So I will switch to that, and then you can always say, hey, Ruthie's smart. I'm going to send her an email and say, can you get together on study with me sometime? So if you need more study sessions, let me know. I can send out an email to everyone saying, somebody wants to meet Sunday night. Can you get together and study? Oh, I think that's all. Should we look at the 10 exercises on measurement? Is that a good thing to do next?
Yeah.
Okay, it's actually not. I'm tricking you. So rounding was due today. It doesn't mean don't turn it in if you don't have it done, because the only thing that having it done on time was turning in 8 sets of 10 exercises on time is an achievement named the danger zone. So that's so I can keep track, and in the future, if you want a letter of recommendation for a job, I can say, yes, Tiffany turned in lots of stuff on time. She's good at time management. But still, turn them in late, better than never. But officially, rounding was due today because no one had questions last time. Today, when we started class, not everyone was here. Some people are still driving home, getting off work, etc. So I want to ask again, anyone have questions about the 10 exercises for fractions or percents? Because if you don't, then those will be due on Tuesday on our next class. Anyone want to do that before we move on to measurement?
I think I was stuck on a certain one, but I don't remember which one it was on that I told you I was stuck on.
I had a problem I was stuck on, and I think it was on the percent format.
Percent format, which one?
I was stuck on number 5, 6, and I believe 10.
Okay, 6 I was expecting someone to ask. That one I purposefully sort of left as a challenge problem.
Yeah, that's the one I was stuck on, I believe.
Okay, let's do 5 and 6 and 10 together. So we're still now back on percent format. So this one, I'm not going to be able to fit 3 on a certain page, so I will do 2 pages. Okay, so the secret for all of these was that there were 4 ways to do out of 100, and we had to figure out which was the easiest in our situation. So if I wanted to go from percent to fraction, I can replace that percent sign with something, which was the easiest one to do.
Write as fraction.
Write it as a fraction, put it over 100. And the tricky part of this problem isn't actually the percent format to fraction format. It's that now you're supposed to reduce a fraction that has this decimal in the top part. How do I make that a nice answer? And I'm happy to just tell you, because we haven't seen it before in class, but if anyone wants to show off, what do I do? How do I get that kind of cleaned up?
Would you multiply by 10?
I do. So I can do a decimal scoot, right? A times 10, top and bottom. And that makes that icky 0.8 just turn into an 8. Then I can do divided by 8, top and bottom. If you wanted to do divided by 4 or 2 and take more steps, you can, but I'm running out of room. And you get your answer. If this was a different problem and it was 0.75 over something, how many decimal scoots would we do top and bottom to clean up that?
2.
2, right? I'd get 75 over 400. So however many scoots you need to clean up the decimal, and then you can be done. Okay, 6. This is completely unrealistic. I have 25 3/8% as a fraction. I'm going to start by turning that into an improper fraction. I will say, by the way, 25 3/8 is going to be 25 times 8, and then plus 3, all over 8. So that gives me 203/8. Everyone remember how to do mixed numbers into improper fractions?
Yes.
Multiply these two, add that one, stick it over the old denominator. So what I really want to do is take 203/8 as a percent and get rid of the percent sign by writing it as one of those 4 things. Now, which one am I going to pick?
Would it be multiply 1 over 100?
Yeah, this is the only time you ever pick that one, is if you had a fraction inside the percent symbol to start with. And we haven't officially done multiplying fractions, but you go across the top and bottom separately. 203 times 1, 8 times 100. And that doesn't reduce because your teacher loves you, and you're just done. So number 6, I always have to do on the board, partly because we haven't done fraction multiplying, and partly because picking this one just never happens in real life, because you never actually see that kind of percent. But now you are super educated. You could even do that one. Questions about those before I move off the slide?
I'm good.
I understand now.
Okay, 33 1/3%. I want to write that as a fraction. So I would do the same thing. 33 times 3 is 99, plus 1 is 100 thirds. I want to replace the percent. I have a fraction in the percent thing. So I would take my 100 thirds and replace it by the times 1 over 100. This is just a warm up for canceling. We'll talk about canceling soon. And we get 1/3. If you don't know about fraction multiplication and canceling yet, you could also just think that this is 1/3 of 100. 3 of these make 100. So it's going to be 1/3 of 1, because 100% is a whole. Okay, so we had questions on the percent, which is good. We're not moving too fast. So I'm now in the syllabus. If you go down to the calendar and I reload it, then shape-shifting fractions is, oops, I put it on Monday. That's not going to work. Is going to be due next class. And the percents, we don't have a due date yet because it might have more questions next time. Okay, now fractions is due next time. Let's look at the 10 exercises for measurement. So feet to yards, miles to feet, yards to miles, millimeters to centimeters, millimeters to meters, centimeters to kilometers, then some stuff with ounces and pounds and grams and kilograms. And gallons had fluid ounces as the parts of a cup, liters and milliliters. So all things we've done. Do you want to work on them together some now? Do you want to wait till our 7:50 time study session and keep going on with new stuff now? What would make you happy?
I would like to work on them together.
Work on them together? Sure. So I'm going to, let's see. Should we take a 5 or 10 minute break now instead of at 7:50 if we're sort of transitioning earlier? Let people get a quick bite to eat or drink or use the bathroom or get out some pencil and paper or things like that.
Yeah.
Yeah. So again, where we are is in the shape shifting down at the bottom, the 10 exercises for measurement. get ready to work on those and we'll talk about it, and I'll see you in a few minutes. Okay, study session. We needed a hint for number 3, that 1 mile had 1,760 yards. And number 9 is a little tricky, so we're doing it on its own board. From the lecture, we had that 4 and 4 and 4 and 4 was 16 cups in a gallon. And we also had seen that 1 cup is 8 fluid ounces. That was briefly mentioned. If you missed it, quite understandable. So each of these little cups is going to be 8 ounces, 8 fluid ounces. So we have 8 and 8 and 8 and 8 and 8 and 8, 16 times. So overall, we have 1 gallon is, why am I writing it there? Sorry. Yeah. So 1 gallon is the 16 times the 8. Because each of the 16 cups, if I was to draw in all of the cups, each of my 16 cups is 8 ounces. So 16 eighths. I'm not sure.
128.
Yep.
Don't wake her up.
Ta-da.
Thank you.
You're welcome. I hope my picture helped. Not everyone likes the pictures.
Oh, I love the pictures. They help me so much. I'm pretty rusty, so they help tremendously.
It's different though. That there are rusty people that just the pictures confuse them, and there are rusty people that love the pictures, and there's people that aren't rusty that have just never had it explained with pictures, and they like the pictures too. So hopefully something makes everyone happy, even if not everything makes everyone happy. Okay, I'm going to pause the recording again while you keep working, and when you need me, I'm here. Okay, I forgot the recording of number 10 using the shortcut. The hard part is remembering that unit is the plain unit, liters in this case, because there's no like L for liters on the list. Now we're doing number 2. So we are not staying in the SI system. We have to not use a shortcut and actually think about this thing. So I'm going to write out 7.1 miles. And I have to know how to get from one unit to another. So what was the number of miles per feet or feet per mile? How did we go? What do we know?
There's 5,280 feet in a mile.
Yes. So go back to that lecture part about the history if you needed to get that number. Okay, so is miles the bigger thing, the one that's a multiple of feet, or is miles the smaller thing? It's a factor of feet.
I'm sorry, I was having a hard time hearing you. Could you restate that question?
Sure, it's an obvious question, but the right one to ask. Is miles a multiple of the feet we're going into, or is mile a factor and feet's the bigger one?
Sorry, hang on. I think I might have a download going on my computer. Hang on.
Pick top or bottom?
Is it miles?
We're starting in miles.
All right, I think I fixed it now.
Okay, so is miles a multiple of where we're going or a factor of where we're going, which is feet?
Multiple.
Multiple. There's lots of feet in our mile, right? A mile is multiple feet. So that means we're going to multiply.
Yeah, I was just a little confused because I believe I did 7.1 times 5,280 and got 37,488 feet.
Is that not on the answer key?
Just wondering. That's it.
Let's check. So if I go on one of these tabs, it's probably it. Right?
Yeah, it's in there.
Yep, it's there.